go ahead and go over this study guide for this semester test. Okay. So what are 6 centimeters equal to? Let's go ahead and try to convert that to meters or millimeters. I mean, we can go either way. Big guy, little guy method. We did that before. So we have 6 centimeters to millimeters. Which one is big? Centimeter. That's a big guy. Negative second power. Milli, that's a little guy. All right, going from big to little, I'm finna go to the right. 1 power 10. That's the difference. If you had like a number line, that was a crooked one. Fix that. Well, I'm gonna keep on going back. All right. So I had number line. We have -3 before -2. So going to the left direction, the numbers get like smaller per se as far as the unit values. All right. So it'll be more places after the decimal. All right. So a difference of 1 right here. Because I'm getting smaller units, I'm going to go to the right. It's part of the rules we learned before. So that it'd be like 60 millimeters. Forget those old rules. Now, if I'm going to meters, so if I have 60 centimeters to meters, that's a -2. Meters are base unit 0. So I'm going from little to big, going to the left. Start with L, going to the left. Let me erase that 60. So I got 6. How do you go to the left? 2 powers of 10, the difference. So I'll start here. 1, 2. Put the 0 in the ones place as we have to. 600s. All right. So you learn how to convert between units of measurement. You see that on the study guide. Let's try the next one. Which of the following is unique to any given element? That would be. Do I want to pen this or type it? That would be the protons. All right. So the protons. Protons are unique. Number of protons. Okay. Which statement is true about oxygen 17 and 18? Notice these are the atomic masses. They are isotopes. Same number of protons with different neutrons. We have different masses. Now, as you go from left to right across a period, the number of valence electrons it increases. All right. The tendency of an element to react is closely related to the valence electrons. Or valency. Valency, the electron, negative sign. In the electron dot diagram, we call this a Lewis dot structure. The symbol for an element is used to represent what? Oh, oops, got a bad light. So that would be the nucleus and the non-valence electrons. That's the well, excuse me, that'd be the valence electrons. Electron dot diagram is used to represent the valence electrons. I'll put VE for valence electrons. Okay. All right. In a compound MgCl2, that little subscript 2 indicates the number of chlorine atoms. All right. There are 2 chlorine ions on that magnesium. So it's 2 chlorine ions. Oops. From the E ions. Maybe I should type this. I don't know. I'm doing this on the fly, so y'all be patient with me. All right. Now, it's going to ask you on this one. Go back. It's going to ask you about the nucleus. Excuse me, the nucleus. That's the protons. All right, that's the protons or the chemical symbol. Like for electron dot diagram for helium, we He. Helium, has two protons. We're just gonna put helium there. Protons and the valence electrons around there in the Lewis dot diagram. All right. So the name iron 2 indicates that it wants to give away two electrons, so it has a charge of 2 plus. Number 9, in the name carbon dioxide, the prefix of the second word indicates that the molecule of carbon dioxide contains two oxygens or two oxygen atoms. All right, now 10. The substances that undergo change in the chemical reaction after after it goes from the reactants, it changes into what? Products. So those will be the products. Well, let me read it again. The reactants. It'd be the reactants, the substances that undergo change before it goes on a change. I'll call the reactants. So I'm gonna put reactants there. Substances that undergo change. So before they change, they're called reactants. Okay. All right. Methane. It changed that CH with a lowercase 4. It burns an oxygen to produce. So we got CH4, subscript 4, burns an oxygen. So it'd be that plus O2 gas. It says to form, reaction arrow, water, dihydrogen monoxide, and plus sign, carbon dioxide, CO2. Is this formula balanced? Heck no, it's not. But these are the raw ingredients, okay? So in order to have this balance, I need to have 2 moles or two substances of oxygen there. And then I have one methane molecule at the very minimum for this to burn into a complete reaction. That's why we're doing this, for a complete reaction with no leftover side products. It'd be one molecule, uh, or one ratio molecule of methane, two ratio molecules of oxygen. It would give me two. It's gonna look kind of sloppy the way I'm using this tool. Two waters, and that's it. So I need for one of them, two of those. Give me two of those and one of those. Okay. All right. It's not the prettiest. I don't like that. Should change colors, but H2O. All right. 12. In a compound, chemical energy is contained in what? Where does chemical energy? Where's it stored? Where's it stored? Besides contain, the word stored. It's in bonds, chemical bonds. That's the electrostatic energy that atoms share when they overlap their electron clouds, their valencies. It makes a bond back and forth. All right. In terms of energy, how would you classify this chemical reaction? So I have 2 moles, MOLES, or two amounts of substance of copper plus oxygen. They react to create something called copper oxide. So we got two copper oxides plus 315 kJ. So that's kilojoules. All right. So kilojoules. Is this an endothermic or exothermic? I produce energy. I didn't take in energy here. These two mixed together and energy came out. So that would be exothermic. EXO, thermic. I feel like clicking between drawing tools. All right, the total amount of energy before and after a chemical reaction is the same Thus, energy is what? Conserved. Oh, Lord. We got 25 questions. Almost done. All right, in general, if the temperature of a chemical reaction is increased, what happens to the rate? If you cooking, you turn up the heat on the eggs. Yeah, it increases. Oh, let me erase that typos. Crap, it's raining too much. Y'all hear all this rain behind me? CRAS. Good grief. So getting tired. About all I had is coffee. Mm, late night coffee. It's 5:30. All right. All right. The SI unit for force. That's named after the big dog, Isaac Newton. Big dog. All right. 17. When an unbalanced force acts upon an object, I mean, the object has to move. So we understand that when they're balanced, the object like stays there, right? The table, the way the gravity in the book, the table, is balanced forces because it's not moving. So the object moves. Another word we can substitute for moving, we call this accelerates. It changes position. So RATES, capital R, accelerates. Dang, come down. Set this thing off. It accelerates. I hope you get that. Things acting funny. Okay. It sails short. Are you gonna move? Okay, stay there. Don't move. Don't move. Don't move. All right. When a pair of balanced forces acts on the object, the net force that results is zero. Zero or zero. Hope him and Trey work it out. All right. 19. As you push a cereal box across the tabletop, the sliding friction acting on the box does what? The sliding friction go in that same direction? Does it push it down? Is it greater than the static friction? Or it goes in the opposite direction? Opposite direction. So it opposes. Opposite. I think I can make that change like Michael Jackson said. Hold up. Can I make that change? I think I can make that change. I make that change. I'm tired of that. I wasn't gonna do it. I get that color. I might mess it on my little worksheets class. Just don't. All right. All right. An orange roll off the top of the cafeteria tray. Y'all usually like throw them though. Y'all don't be eating oranges. All right. So when you suddenly stop, let's say you walking and Jamarion bumps into you, right? And the little orange right there on top. He bumps Jamarion. Oh, he's real polite. Like, excuse me. He'll say, excuse me. He's a gentleman. He's a gentleman. And the orange is going to go flying off in the far distance. Okay, it's gonna go that way. It's gone. Say bye bye to that orange now. All right, why does it do that? Why is it when Roscoe bumped into y'all by accident because he's a gentleman, and the orange just doesn't stay there? What occurs? No, it's inertia. It's inertia because the orange really want to be at rest, right? You know what I'm saying? So it's the inertia thing, right? So that's that's uh that's why the orange doesn't do it. It's inertia. Right? So orange is going to roll off. It won't just roll off sometime. If Roscoe bump into you, may go a little further than the roll. Shout out to Roscoe. Everybody shout out to Roscoe. Deuces. All right. If a force of 12 newtons is applied to an object with a mass of 2 kilograms, the object will accelerate. Okay. So force of 12 newtons. So you guys need to understand. See, that's why I want my marker. Should never left it. Draw. Got to draw again. So force equals mass times acceleration. I'm going to, this is a linear equation again, and it was asking for deceleration. I got to solve for A. I'm plugging my values. I have 12, which is my force, measured in newtons, equals mass is 2 kilograms times A. All right, what can I multiply to 2 to get to 12? All right, is it 2, 3, 4, 5? Hand camera, 5. All I do is divide away. Come back here. Come back here. All right, divide away by 2. 2 on both sides. So A will equal 6. It'll be 6 meters per second squared. I'm not showing all the units. I'm not typing all the units. So get on back over here. Newton's third law of motion. What does that describe? It's describe how forces interact. It's action and reaction forces. So it's action, reaction forces. All right. Can I highlight that? They ain't gonna do it. I'm not gonna trip. All right. So y'all just pay attention on that one. I cater it. I say the product of an object's mass and velocity is its what? So what is that? So what is mass times velocity? That equals momentum. That's it. Okay, that's 23. All right, more math. What is the momentum of a 50 kilogram ice skater gliding across the sheet over the ice, the sheet of ice, but the ice at a speed of 5 meters per second? So that's the formula. Give me the mass, and here's the velocity. So what's the momentum? I'm gonna take these two. My drawing tools. I'll take these two numbers. Plug it into the formula that I just used. Amen. And I'm going to do some multiplication. Hallelujah. So what would that be? So what would the momentum be? What would that mo be? Mo, it'd be 250. 250 kilograms, kg, times meters per second. The last one, the gravitational forces between two objects increases. So I have two objects. Uh, all right, that's better. I have two objects. I want to increase their gravitational forces. All right, it will increase if these objects are larger and the what? Oops, get off that. Talk about this mass. Increase it in mass or about the distance. So mass and distance. Will the increase the further they are apart, will the gravitational forces increase the closer that they are? As we shorten that distance, it would it will increase, or I say, or as the distance decrease. So the gravitational force between two objects increase as the mass increase, or the distance decrease. Okay. Do I have to highlight that one too? I think I will, just to be nice. Okay. So that's it. There you have it. There it is. I'd like to thank you for joining us today. Uh, That's me and my drink and my coffee. Well, my tea. Holla.